Hi friends, welcome to the next session of alcohols, phenols and ethers. In this session, we discuss about the chemical properties of alcohols. That is the part second. Okay. In this session, we discuss about dehydration of alcohol. As you know, dehydration we have already studied in the 11th science. What is dehydration? Dehydration, it is the removal of water molecule from alcohol and it gives the alkene, that is called dehydration of alcohol. Okay, for this dehydration process dehydrating agent is required, otherwise dehydration is not carried out. Okay, then dehydrating agent, there are the number of dehydrating agents. Okay, first concentrated sulfuric acid, this is the dehydrating agent. Then second alumina, then phosphorus pentoxide, then phosphoric acid. These are all dehydrating agent. In your syllabus, there is a reaction of concentrated sulfuric acid and alumina. Okay. First of all, we discuss about the dehydration by concentrated sulfuric acid. Okay. For this, first reaction from primary alcohol. Okay. This see here prime example of primary alcohol, that is the ethyl alcohol. This ethyl alcohol is heated with 95% sulfuric acid at 443 Kelvin temperature. Then it gives ethene and water. See here, from this carbon OH group and from this carbon hydrogen. This H and OH, it gives S2. Okay, and remaining portion is CH2 double bond CH2, that is ethene. Okay, this is the example of primary alcohol. Then secondary alcohol. Example, first example, it is the isopropyl alcohol. This isopropyl alcohol is heated with 60% sulfuric acid at 373 Kelvin temperature. Then it gives propene and water. See here, from this OH and from this H or from this H, and it gives propene. Okay, and OH and H, it gives the S2. But in case of secondary butyl alcohol, in accordance, it gives accordance to Sedgwick rule, it gives the two products. Okay, that is the but2ene and but1. What is Sedgwick rule? Sedgwick rule is that the reaction gives more highly substituted alkene as the major product. See here, in the secondary butyl alcohol, as you know, the secondary butyl alcohol, or it is also called as butane 2-ol. This butane 2-ol is heated with 60% H2SO4 at 373 Kelvin temperature. Then it gives but2ene and but1ene. Okay, there are the two products. But what Sedgwick rule is that the reaction gives more highly substituted alkene. In this but2ene, it is the more highly substituted alkene as compared to but1ene. Hence, this but2ene, it is the major product and but1ene is the minor product. Okay. Then the example of tertiary alcohol. Tertiary alcohol. For example, tertiary butyl alcohol. Tertiary butyl alcohol is heated with 20% sulfuric acid at 363 Kelvin temperature. Then it gives a product that is isobutylene, CS3C, CS3 double bond CH2 and water bond. This is isobutylene. See preparation. From this carbon atom OH group and from this carbon atom hydrogen atom, it is replaced and it gives CS3 CS3 double bond CH2, that is the isobutyl, okay, and water molecule. Then next portion, that is the dehydration by alumina. See here, first primary alcohol, reaction with primary alcohol. For example, CS3CH2OH, that is ethyl alcohol, is heated with alumina at 6 to 3 Kelvin temperature. Then from this carbon OH group and from this carbon hydrogen is replaced and it gives CH2 double bond CH2 and water, that is ethene. Second, secondary alcohol. Example, it is isopropyl alcohol. This isopropyl alcohol is heated with alumina at 523 Kelvin temperature. Then it gives CS3 CH double bond CS2 and water molecule. This is propene. Then third, tertiary alcohol. For example, tertiary butyl alcohol. Tertiary butyl alcohol is heated with alumina at 423 Kelvin temperature. Then it gives CS3 CS3 double bond CH2, that is isobutylene and water. Always remember, in these three reactions there is a difference of temperature, okay. See here, in the primary alcohol there is 623 Kelvin, in secondary alcohol 523 Kelvin, and in tertiary alcohol it is 423 Kelvin. In this way 100 degree Kelvin is reduced from primary alcohol to tertiary alcohol, and the product of primary alcohol, secondary alcohol and tertiary alcohol are same as dehydration by concentrated sulfuric acid, okay. Then mechanism of dehydration of alcohol. This mechanism of dehydration of alcohol, it involves the three steps, okay. First step, that is the formation of protonated alcohol. In this step, alcohol is protonated by H positive ion and it gives the protonated alcohol. See here, OH, there is the negative charge on H positive gets attached to this oxygen atom and it gives the OH2 group, okay. That is the protonated alcohol. It is the intermediate product, okay. In the second step, formation of carbocation from this protonated alcohol, this bond is break up and it gives the water molecule, and remaining portion it is the carbocation. On this carbon, it acquires one is the positive charge and it gives the carbocation. Okay. Then in the step third, that is the formation of alkene. See here, from this carbocation, from this carbocation, one of the hydrogen in this way, this hydrogen atom is removed and it gives alkene. And this H positive ion, it is regenerated again. Okay. Then we discuss about the conversion of propane 1-ol to propane 2-ol. There are the two reactions. First reaction, it is the dehydration of alcohol reaction, and another is the dehydration of alcohol reaction, and another is the hydration of alkene. See here, this it is the propane 1-ol. This is the propane 1-ol is heated with aluminum at 623 Kelvin temperature. Then it gives the propene and water. Okay. Then this propene is heated with concentrated H2SO4. We have already discussed in the hydration of alkene. Okay. And this propane, it gives the propane 2-ol. Okay. And this conversion frequently asked in the examination. Okay. Then next chemical properties of alcohol, that is the oxidation of alcohol. As you know, oxidation is the addition of atomic oxygen. Okay, and this atomic oxygen, it is obtained from oxidizing agent. See here, there are the number of oxidizing agent. First, acidified potassium dichromate, that is K2Cr2O7 plus H2SO4. This K2Cr2O7 and H2SO4, it gives the atomic oxygen. Okay. Then second, alkaline or acidified potassium permanganate. This also gives the atomic oxygen. Then chromium trioxide. Then fourth, PCC. It is the pyridinium chlorochromate. Okay, this is the fourth oxidizing agent. And these four oxidizing agents, it gives the atomic oxygen. And then this atomic oxygen, it is used for the oxidation of alcohol. First of all, we discuss about the primary alcohol. For this primary alcohol, oxidation of primary alcohol. See here the example of primary alcohol. It is the ethyl alcohol. This ethyl alcohol is oxidized by acidified potassium dichromate. Then it gives the acetaldehyde and water. Okay. Then this acetaldehyde again oxidized by acidified potassium dichromate and it gives the acetic acid. Okay. First it gives the aldehyde and second on oxidation it gives the acid. Okay. Then secondary alcohol. For example, isopropyl alcohol. This isopropyl alcohol is oxidized by acidified potassium dichromate and it gives acetone. This is the example of ketone. Okay. And water. That means this primary alcohol on oxidation it gives the aldehyde and further oxidation it gives the acid, and secondary alcohol on oxidation it gives the ketone. Okay. Then tertiary alcohol. But in case of tertiary alcohol, there is no alpha hydrogen atom. Hence, this tertiary alcohol not easily oxidized. For the oxidation of tertiary alcohol, strong oxidizing agent is required, like chromium oxide. See here the example of tertiary alcohol. This tertiary butyl alcohol, on heating it gives the isobutylene. Okay. First of all, it dehydrates to give the isobutylene, and then this isobutylene on oxidized with chromium oxide and it gives the acetone, and one methyl group converted into carbon dioxide and water. Okay. Then next property, action of copper. See here, first primary alcohol. Primary alcohol is heated copper at 573 Kelvin temperature, then it gives aldehyde with the liberation of hydrogen gas. For example, ethyl alcohol. This ethyl alcohol, it is heated with copper at 573 Kelvin temperature, and it is oxidized to give the acetaldehyde with the liberation of hydrogen gas. Then secondary alcohol. This second, for example, isopropyl alcohol. This isopropyl alcohol is oxidized by copper at 573 Kelvin temperature. Then it gives the acetone with the liberation of hydrogen gas. But in case of tertiary alcohol, for example, tertiary butyl alcohol, it is dehydrated by copper at 573 Kelvin temperature, and on dehydration it removes the water molecule and gives isobutylene. Okay, see the difference between primary, secondary and tertiary alcohol. This primary and secondary alcohol, it gives aldehyde and ketone by oxidation, but in case of tertiary alcohol, it is the dehydration reaction. Okay, hence the chemical properties of alcohol is completed.